And we are live with the next talk for Meeting C++ 2023. Today, this talk is with our new speaker, Mikhail Svetkin. Really looking forward to your interesting talk. Also kind of interested in the same thing and starting C++ projects in the modern age. So I'm really curious to see what you have to say. Please take it away, Mikhail.
Hello, welcome everybody. And today we're going to talk about how to start a modern C++ project. My name is Mikhail Svetkin, and let's look at our agenda. So the first thing is we're going to talk a little bit of my motivation. We'll try to start a new C++ project. We'll talk about build tools, project layout, tooling, dependency management, continuous integration, and even look at some IDEs. Basically, everything what you need for to create a project. So before we go, a little bit about me. I'm a principal software engineer at Remarkable. I'm a C++ programmer for the last 12 years, I believe. Mostly I was interested in some more low-level stuff, like networking, framework libraries, build systems, not that much. Yes, and I usually don't like to talk about myself, as you can see. I'm very shy, but today I think I need to tell about my journey. I think it's very relevant to the context to understand how hard it is to start a C++ project. So I started as a bare metal developer, and it was C and some C++. Then I started to work with the real-time operating system. It was also a mix of C and C++. And at some point, I moved to develop Linux kernel, and there was zero C++. And by that time, I wasn't sure what I want to do. But at some point, I kind of, once I touched C++, I didn't want to go back. So I quickly switched to work with embedded Linux. And when I started to work with embedded Linux, I almost the same time started to work with the regular Linux. I don't think there is a big difference between them, but people called it differently, so I just followed the tradition. When I started to work with the Linux, I also started to work cross-platform. So that means I started to develop my application also for Windows and Mac. And then I touched mobile development and even web development. Most of my journey was C++ related in that regard. And oh yeah, forgot to mention that I also developed some frameworks, yes. The interesting thing is what was the common between all of these jobs. And if we just look at one job, another one, and yet another one, so the common was only a subset of C++. So, but what was more interesting is what was the differences. The hostess was different, the build tool was different, C++ standard was different, subset of C++ was different. Sometimes you're allowed to use templates, sometimes you're allowed to use virtual keyword or exceptions or return code or RTTI. Like it's so many things in C++ and depends on the project and requirements. You might not able to use any of them. So there was also different libraries. I highlight two of the big ones, like Boost and Qt. And yeah, some projects was based on Qt, some projects was based on Boost, and many other small libraries around. The project layout was completely different. And it's basically from project to project, you can adapt completely something new. Continuous integration and continuous deployment was different. Dependency management was different. I remember when I just started, there was basically no dependency management at all. So it was a completely different world back then. And the tooling around was also different. So what did I learn? I learned that everybody used C++, but differently. I learned that everybody built C++, but differently. I also learned that everybody used some tooling, but with the different options. I also learned that some best practices are the same, and I think C++ now has a lot of good practices around, like don't use new, use the smart pointers, and you can find a lot of things on core guidelines, C++ core guidelines. So I think there is a big adaptation of these practices nowadays, but still, sometimes they're different. And it also depends on the project. So a bit of my motivation after I told you my journey. So 1 year ago, I started to learn Rust. And I was quite surprised how easy it is to set up a project, how basically easy to build stuff, easy to manage the dependencies. And I was very surprised. So also I looked at the Go language. It wasn't that straightforward at some point as Rust, but it has a good default, I would say. And also one of the motivation was CPP front. For those who doesn't know, CPP front is the like TypeScript for C++ from Herb Sutter. And particularly I was interested in that slide, which you can see, where Herb Sutter says like it's basically CPP front is one CPP file and you can build easily just like that. And I was curious, is it like that? So I decided to try to create a modern C++ project and see if we can do that, as Herb Sutter described in that slide. So let's create a modern C++ project. Let's take a look at this pretty simple example where we have a hello world, very traditional one. And let's try to compile it. We will compile it with GCC first, and we will get our hello world. Then we can compile this Clang that, and we will get our hello world as well. And we can compile it with the MSVC, and suddenly we're getting our first error. A bit spoilers, we'll get a lot of errors today. So, and if you look at the error, it says EOStream, not include path, so kind of not really understandable. But turns out what you need to do is you need to first prepare the development environment. You need to execute a script which will set up all the path and environment variables required by MSVC compiler. For those who never developed in Windows, might be kind of surprised by that. But yeah, after that, you can compile and get your hello world. Very easy. Next one is the Clang. It's like a wrapper for the MSVC, which you can execute. This one will also produce the executable for Windows, but you don't need to set up the development environment in that case. It kind of manages it by itself. Okay. Now let's think, is it actually a modern C++ project? I mean, that hello world looks like, I don't know, 10 years ago. So 1 year ago, I've been at NBC Tech Town, and there was a Timur who was showing the modern new hello world example, which I kind of liked. Just for fun thing, you see on the red rectangle, it's actually me. I didn't do it on purpose, but accidentally I ended up to be in the corner. Yeah, so let's try to replicate that example. And go even a little bit further. We can actually import, instead of print, we can use import std because it's also part of C++ now, modules. So let's make it even more modern. And okay, let's try to compile it. So the first we will take the G++, and we will get our unknown type name import. It doesn't really tell us what's going on, but I guess maybe we need to specify the standard. So I will supply stds equals C++23, and we will get an error, fatal error module std not found. So it turns out that GCC does not support, doesn't provide std library as a module yet. So let's try with Cline, and as you can see, we supplying standard also, but we supply it a bit differently, C++2b. So first difference between the compilers we will see today. And we will also get similar error, and then it turns out that Clang also doesn't provide std as a std module yet, so we cannot use it. So let's try the MSVC, and if we supply, we say the latest standard, you see it's again different. We will get this error. So I was quite upset when the first time compiled. I was like, no, I thought it's supported somewhere at least. But then after a couple of Googling, I found out that you need to execute this couple of commands. And then you finally get the hello world. I am not going to explain why you need to do that, but just showing it, so it's kind of hard. So maybe it was too modern. So let's kind of go back and reflect a bit. So if we cannot use import std quite easily, so let's go back to the print version and try to compile it again. So now we actually compile already with the C++23 standard. And the error again, print no such file directory. Turns out that print is not also has been implemented by GCC. And if the same for Clang, we will not able to get the print. But luckily MSVC now works. They already implemented print, so we can use it and get hello world. So what we're going to do? Should we go back to std cout and EOS streams, or we will able to still be modern enough? And the answer is we actually can use FMT library. It's almost the same as std version, and those who doesn't know, std print is actually based on FMT print, so we can use that one library instead of and be modern still. So let's try to compile, and you will notice that there is 3 red dots. I actually not showing how many flags you need to pass to actually describe where to get FMT library. We'll talk about it later. So just let's imagine that magically works. We will get our hello world. So then if we do the same for Clang, we'll get the hello world. And for MSVC, we again get hello world. Perfect. I think everything looks great, but there is one but. And I still want to use print if it is available, because now I kind of set modern C++ project, one line, but yeah, I want to use print if it's possible. So what we need to do is we need to do something like that. And so what it does is we kind of include version header, which actually tells what kind of features available with standard library. And then when we compile with G++ or Clang, we will check that if cpp print defined, it will be not. So then we will use FMT, and we will get hello world from FMT. Yes, and when we compile with MSVC, it will check that cpp print is defined, and we will use the standard library print. So kind of cool, but I think it kind of becomes mess already. So let's summarize what did we learn. So it might be tricky to start a modern C++ project. You need to be aware what's the standard library supports with the compiler you chose, and kind of tricky sometimes. We also learned that the compilers are not the same, the flags are not the same, standard library implementation is not the same, and there's many, many other caveats which you can find when you build a big project, cross-platform project. Building is tricky, so I said that these 3 dots, you don't need to think how it is and where does the library come from. So the flags are different, so it's a bit tricky, or it becomes tricky quite easily. And the code could become messy very quickly. So if you look at the final version, it's kind of hard to read, hard to understand, and we definitely don't want to write code like that. So what we're going to do after that is that we're going to go through all these 3 major pain points, tries to solve them, and we will try to learn something out of it. So let's start with the compilers are not the same, flags not the same, standard library is not the same. So we need something that unifies that. So we need a build tool. We have many build tools in C++. Which one to choose? It's a very hard question, but I hope I have a very simple answer. And it's called CMake. And I know that CMake is not the favorite build tool in the C++ community. It has a lot of controversy. I would say that it becomes de facto C++ standard tool. And if you look in any survey or polls, you will find, like, for example, this one is from JetBrains, from their ecosystem survey. But most of the projects now migrating to CMake. Also, there is a nice quote, which was in the same survey, is that I'm on record as liking CMake to Stockholm Syndrome for C++ engineers. It has become de facto standard, for better or worse, as demonstrated by the clear lead it holds over its competitors. So, yeah, as I said, not everybody likes CMake. And there is also another survey from ISO CPP, which also clearly shows that CMake is the most popular build tool right now. Also from the same ISO CPP, you can see their major pain points is actually managing CMake projects. It kind of semi-proved that CMake is the C++ build tool. But also there is also interesting other pain points, is like how to set up a development environment. And we saw it clearly, like if you've never worked on Windows, you might don't know what you need to execute. Yeah, people don't know how to, it's like hard to set up the continuous integration pipeline because again, you need to set up the developer environment and many other things. And managing libraries for your application. And as I said, we kind of bypass it right now, but we will come back to that later. Okay, let's start with quick CMake intro. So for those who doesn't know, CMake is a meta build system. It's not actually, CMake is not actually building your CPP files. It's actually generates some platform-specific build files, like Ninja, for example, or Visual Studio files and MS Build and so on. And then you kind of execute them, or CMake execute them for you. It's cross-platform, so it works kind of on all major platforms. It's configurable-ish. The reason I put ish is that you can do so many different things with CMake, and then it's kind of very hard to manage it, as it was shown in the ISO CPP survey. And it's also scalable-ish, so you can kind of build a monorepo with CMake, but at some point you will start noticing that the configuration step is quite hard, building is quite hard. There's many things you will see. So it's scalable until a certain point, in my opinion. Yes. Okay, so let's kind of try to make a small CMake project and look how it looks like. So you need a ergo CPP file, and you need to add the CMake list.txt. And inside this file, you need to say which minimum version you're going to use of CMake. You need to also define the project name and say which languages you want to use. Then you create executable target. Then you tell what kind of sources related to that target. And then you can define some C++ properties. For example, we want to use C++20 standard, and we don't want to use any extensions from the compilers. We want to have a strict. So then, until you have that file, you can call the configure step, and you need to say CMake -b build dot, basically we're pointing where the build folder is going to be and pointing out where's the sources for CMake. And if you don't specify -b build and just ignore it, you will basically, CMake will generate all the madness of file in your source folder. Not really good. So you can think about CMake in that regard. It's similar to C++. It has bad defaults. So you always need to, don't forget to do the right thing. And then until you configure the project, you need to build it. You just say CMake -build, and you supply the build folder, and then it will build for you. And then you can execute your executable. Okay, hello world. So as I said, CMake has bad defaults, and you don't want to kind of all the time remember what to do and how to configure your projects. So there is a solution for that, and it's called CMake presets. CMake's presets is basically two JSON files. One of them you're supposed to keep into your repository. So it's CMake's presets.json. And the second one is CMake user presets. The JSON. This is kind of your user customization point. So the idea, this JSON file is supposed to tell how to configure a project, how to build it, how to test it, how to make a package out of it, and how to run, how to test, not how to run your CI pipeline. So it's basically a way to provide the good defaults for the project. So let's go step by step and look in each of them presets. So first is configure presets. You can say what's the name of the preset. Presets could inherit from each other. You can choose which generator you want to use. For example, I prefer to use Ninja multi-config. You can select Ninja, you can select make files, or you can just don't select anything and then it will choose something by default. You can also supply the binary dir. And as you see now when you kind of invoke your preset, you will always be in the build folder with the preset name. So your source folder will be polluted, which is great. You can also specify the toolchain file. This might be important for those who has worked in some embedded where compiler and flags are not easily foundable or kind of not included with the platform. So you have to have a specific toolchain file. You can also supply some cache variables, which is basically could be your configuration, something from your project. You can supply some environment variables and condition when this preset is available. For example, it could be only Windows preset or only Linux preset, something like that. Once you added the configure preset, you can do a build preset. And the build preset is basically describe how to build it. So yes, you again give a name. The build presets can inherit from another build presets. You can tell which configure, you should actually tell, or you have to tell which configure preset it should be used, because then it knows where is the build folder, then you don't need to show where it is. You can say which targets you want to build. Sometimes you want to build different targets for the different presets. And again, you can supply some environment variable and conditions when that preset is available. And to execute it, you just say CMake -build -preset base. And if you use a Ninja multi-config generator, you can also choose which one you want to build, debug or release or any other configuration. Okay, once we've done the building part, now we need to test our code. And in that regard, CMake provide test presets. And for those who didn't know, CMake has a tool called ctest, which actually is able to run your test code. Most of the modern frameworks in C++ provide integration with ctest, like if gtest or catch. So everything kind of works out of the box. Yes, and again, you can give a name for your preset. You need to say what's the configure preset was to know where the build folder is. You can tell the execution policies. Do you want fast fail? Do you want to repeat? Do you want to, like, how many threads you want to use and so on? Again, you can supply some environment variables, which can affect your running of the test and the condition when this preset is available. And to run the test, you can say ctest -preset, name of the preset, and if the configure preset was a Ninja multi-config, you again can choose, do you want to run debug or release? Once we've done with testing, it's time to make a package. For those who doesn't know, CMake provides a tool called Cppcheck. Cppcheck is able to take all your libraries or executables and package them in different types of packages. For example, you can create a target-z archive or dep package, or some external packages you can use, generators. Yeah. Basically, it looks the same as 3 other before. You give a name, it could inherit from others. You need to say the configure presets. You choose what kind of generators you want to use. In that case, we just want to create a target-z. You can say what kind of configurations that meant to be debug, release, or no. And the variables here is basically variables for the generators, like what's the name, what's the version, and so on. Yes. And to execute, you just say CMake -- preset base -- config release or debug if that's with the Ninja multi-config, or just ignore it. So now we kind of know how to configure, how to build, how to run the tests, how to make the package. Now it's time to go to actually look at our CI. So on CI, basically, you want to run all of these 4 tests or 4 steps in one. And that's why CMake added the workflow preset, which basically you just describe what kind of configure step you want to run, what kind of build step you want to run, test and package. That's all. And then you just execute CMake workflow and the name of your workflow. That's all. And that's basically configures your project, builds your project, tests your project, and if everything is passed, you will get the package, which is quite nice. So now, like, all the defaults are good because you, as a developer of your project, you set up everything what you needed, and it's kind of easy to share with friends. One last thing about CMake and presets is that naming is quite hard. So I, in my experience, come up to something like that. This is basically a way how LLVM called their triplets. So it's basically architecture, OS, compiler, and linkage. So some few examples, like I want to configure my project for x64, Linux, GCC, and all the libraries should be static, or like dynamic. Or for example, for Windows, that could be look something like that. This is just me, how I like to name the presets, but choose wherever you want. But I feel this is very kind of convenient. You know exactly what you're building for. And if somebody wondering right now, can you select a default preset based on hostess? That is impossible, unfortunately. So you will have to type something. Okay. Now we kind of know the CMake, and let's actually look at how to structure the C++ project. To be able to explain how to structure the project, I will refer to this talk by Mateusz Pus about modern project structure. I find it quite nice. I tried it for many years and it works for me well. But let me explain how that works. So basically, when you create a C++ project based on CMake, you need to follow this pattern where everything on the top of the project is basically a developer entry. This is where you enable all your development features like dependency management, warning, test, docs, cache, wherever you want. And when you as a developer use it, all these features enabled and everything is good. But when somebody consumes your project, because you actually don't know sometimes how's your project is going to be, because if you make a library, maybe somebody will use your as an add subdirectory, maybe it will be a Git submodule, maybe it's going to be used through the package management. So it's nice to have the source as a separate CMake project. It's kind of, it's, as I said, it's center point for consumers, for like add subdirectory or package managers. It does not affect development environment. You're not in control here of which C++ standard it's going to be used, what's the warning levels, and so on. All of this is kind of done on top, but the consumers, they just consume your project, your library, your application, wherever it's there. And if you look inside the source folder, each of the subfolder is basically a module which you can enable or disable quite easily, like a comment and uncomment subdirectory. So it's very modular, and the pattern repeats kind of itself. Everything inside looks similar. It was on a level above. So let's add a CMake to our C++ project. So just reminder how it was. We had this if-def, quite messy. So let's assume we are going to do something like that. So basically, we moved all the logic to the debug HPP, and we have one function called debug, and based on the compiler or implementation standard library, we will choose either for example, G++ Clang will use MCPP print, and which will refer to FMT print. And MSVC, since it has a support of std print, so we will call std print. So just some goal for us. Let's see how it will. How do we need to add a CMake for this project? Okay. First of all, we need to add a CMake list.txt, and we will set the minimum requirement of CMake. We will say the project name, and as you see, I called it a dev, MCPP dev, which means like this is highlight. This is for developers, not for the users. And here we will enable all the cache, extra warnings, docs generation, testing, and everything what consumers doesn't really care. And then if we look at the source folder, there is also another CMake file. We also define the project, and this one actually has a real name, MCPP. Yes, we do say again version, language, everything it was. I have one helper function here at MCPP module. We're not going to look into it. It's basically sets all the good defaults one. Yeah. And then we add our modules like log and my application. So if we look at the log, it's also kind of, we calling this add MCPP module, which creates a target for us. We say it's interface. CMake has this thing called static shared and interface. And you can create static libraries, you can create shared libraries, and interfaces like header only. Since we don't have any CPP files, we need to explicitly say this is a header only library. So yeah, as I said, we create a target, we source the files, then we check if it's not MSVC, and then try to find FMT somewhere, and then we say that our library depends on FMT. And we also set the define that we know that we need to use FMT. So that's how it will look like our debug file, debug HPP. So if the MCPP use FMT is defined, then we use FMT core. If not, we will use print. And the implementation of the debug is not really important. It's just, it will be kind of similar. Also important when you set up a project is create tests. And here's an example. We see the test folder, it kind of follows the same structure as source. And if you have a log module, you will have a log subfolder where you basically have a test file per header. And even if you're not going to write any test itself, it's very nice to have a simple test file, which just check that include is correct, that everything is fine, that you didn't forget some includes or something. So it's basically a sanity check for the headers. It's quite simple, and I really recommend you to do it because you never know that everything works until you compile it and test it everywhere. Okay, then let's look at our executable. Create executable, we source the main CPP, and then we say that we are depending on the log library. So pretty simple. Let's try to compile it. And for that, I would use workflows. So I will compile for Linux GCC dynamic and Linux CLion dynamic, and you will see both of them get the hello world. So quite simple, quite nice, and I would say it's pretty, looks like standard REST here. Now I kind of want to share my project to my friend and see if he will able to use it. And for that, I'm kind of trying to silly transfer to the version control topic. I know that I hope that everybody nowadays use version control, so there is no debate into that. But I'll still will explain why you need to use it. So it's basically a history tracking, you know, why this line was there, what was the reason. It's kind of nice, the collaboration. This is a set. I'm trying to use it as an example here that I will share it with my friend. Backup and recovery. I'm not sure how was it with you, but I remember when I was started at my workplace, we didn't use version control and everything was on the local disk on a hard drive. And at some point it was dead. So it's kind of, we was luckily that was not a big project on that hard drive, but it was still like a year of work. So it's kind of nice, you know, to have something like that. And of course, choose wherever suits you most. I personally like Git and GitHub, but sure, choose wherever you want. Just have something. It's better than nothing. And quickly, a few tips and tricks. I've recently been doing a huge refactoring. It was basically Clang format changes and some style changes. And I've noticed that it's kind of, if I use the Git, then my kind of Git history is broken. So I found a way that you can say Git to ignore some specific commit in the history, that the history will be when you do Git blame is actually okay. So the one reason, the problem is that Git kind of doesn't have a native good integration. So you need to have a file which called git blame ignore refs file. And you need to specifically say that, oh, Git, you need to use that file to kind of ignore some refs. And the problem is if you don't add the file in the beginning of your project, then by switching from the branch to branch, and if the file doesn't exist, the git blame is not going to work. So if you start the project, just create that empty file and just leave it there. You know, it will be easier you later when you switch between the branches. And of course, use git ignore file, where you just ignore all the unimportant stuff and keep your repository clean and nice and safe. So that being said, let's actually try to share with the friend. So let's say he will clone my project, go to it, execute the workflow as I said, and suddenly it's not going to work. Remember I said about these 3 dots and that somewhere FMT library come from? This is the time to kind of talk about it. Because maybe on my machine, I used Linux and maybe some of the packages installed the FMT and everything worked. But of my friend machine, he doesn't have FMT library. How he knows where to get it, which version to get it. So let's actually talk about package managers a little bit. So if after what I show you, you're still thinking, why do I need package manager that he can just install it? I want to show you this. This is a wiki page of how to build Qt 5 from Git. And yeah, just look at it. It's kind of hard to see, but that's the point, is to show on every single Linux distro, you need to install different packages to be able to do something. And such wiki pages get out of date very quickly because the packages rename, version rename, or something else, something goes out. You don't really want to spend time on it. You want some reproducible builds for all of your developers, and I strongly recommend to look at the package management here. So what are the options? Last year at NDC, I did a talk about the dependency management, and I looked at the Cline and VC package. And from my point of view, it's yeah, they're both cool. They're both similar. They have a bit different approaches. Cline is Python and requires Python. VC package more like native. CMake integration. Cline support multiple build system. So I would say choose anything what you like more, which suits your case. I like VC package more, but that's just my preferences. So yeah, that's why I said let's add VC package to our project and see how it works. So how to integrate VC package to CMake is quite simple. We take our configured preset and we point out to VC package toolchain file. That's basically it. So, and again, this is the beauty of the presets, that now everybody will get it automatically. And you don't need to kind of additionally inform the developers. And also cool of VC package that it just works out of the box, which is called, of course, security. And then you need to add the VC package.json, and then you just specify your dependencies, like FMT and catch2 as a test framework. So let's try to share with the friend again. Yes, I'm adding my changes to the Git. I commit it, push, my friend get pull, rebase, call the overflow, and now everything is great. The way SVC package works is that it runs before, kind of as part of configuration step, but before the actual CMake stuff. So it's first install all the dependencies, and then the regular CMake kind of runs. So cool. Now I decided let's share a friend with another friend. I have a lot of friends, and this one is actually using Windows. And again, something is not going to work. And I also love the C++ errors. They're so descriptive, and this is actually a real error. When I run, I got this one. And for those who are wondering, what's the error as actually? If we go back to slide where I showed you debug.hpp, I kind of added the space. So if you notice it during the listening me, +1 to you. But if you don't, that's quite fine, because it's very hard to parse the C++ with UIs and understand that everything is correct. So yeah, I deliberately added the space, and my point was to show is that even though something works on one platform, it doesn't mean that it works on another one. So, and that is my way to introduce the continuous integration. So what to do with CI? So I think there's many things you can do with CI, but you need to do at least a few things. With C++, you need to at least build on Windows and Linux and Mac your project. All of them has a different compilers with a different standard libraries. So it will provide you the biggest, I think, coverage in C++ world. And we know that all compilers a bit different, so you'll get a very good coverage to at least know that your project is buildable. In my experience, it was quite common. You worked for many years on Linux, and then okay, now we need to add support for Windows, and then you spend, I don't know, depends on the project, an amount of months. So yeah, and then one thing is to fix the build errors. The second one is runtime errors, because in C++ there is a lot of undefined behaviors, so you never know. Yes, so build at least with GCC and Clang and MSVC. Clang has support two standard libraries. It can be worked with GCC, and it has its own. So I recommend to build with both, just to increase the coverage, I would say, test coverage that way. Yes, I would also recommend build at least debug and release versions, because the debug version is usually not optimized and release is optimized. You will get different results. Sometimes compilers optimize too much, and maybe you wrote code not in a good way, so it actually will cause a problem. But sometimes you basically, the debug build will not work for some reason, because compiler was actually optimizing on and fixing problems, and the debug one doesn't work. I would also recommend to run some static analyzers like Cppcheck and Clang-Tidy, because they will also check and notice what kind of errors do you have in your project. Okay, so I want to suggest to add the GitHub actions, because as I said in the beginning, I like Git and GitHub, and I need some simple examples, so I will just show you how to do it. So for those who doesn't know, GitHub actions is basically a YAML-based thing. So you need to create a YAML file where you describe on which events, like push and pull request, you want to run your job. Then you select what kind of OS you want and define the strategy. So just for example, how it could look like, We define the strategy. We want to fail fast. Our metrics is going to be we want to run on Ubuntu, on Windows, on macOS, and we will choose these of the presets to run on. And then basically we describe step of our continuous integration. So we need a checkout to get actual the changes. We need to install system dependencies. Basically what we need to install is like a compiler, CMake, Ninja, maybe something else. All the GitHub runners have pre-installed things, but sometimes the versions could be out of date, or maybe they're too modern, you're not supporting them yet. So it's nice to install things which you're actually working with. And then you just invoke your CMake, as I showed you, workflow, preset, and the name of preset. So it's quite simple, but that basically saves you a lot of trouble if you don't do it at the beginning. And if you think that I'm kind of overcomplicate things and I'm saying this is not really necessary to do, I want to refer to one of them, pull request to FMT Lib. And you can notice that there's actually 40 successful checks to run. And if you look at them, you will see like Linux, GCC debug, GCC 4.8, macOS 11, Windows 2019, Win32, and there's basically a lot. And still in this library, FMT, which largely used by many other projects, there are still bugs, there's still issues. So even building on all of these platforms and running fuzzing doesn't really guarantee you that everything is good. And very often you will see that when a new GCC or Clang is released, there would be a follow-up PR say, okay, now we fix the build errors to that compiler, to the new version. That's quite common to happen. Okay, I want to quickly talk a little bit about the tooling which you can use with the C++ projects. Basically, I would recommend to use some formatters, like a Clang format, which basically format your code. I've been in companies where you don't have a Clang format, and all files kind of either in a different format or people try to manually review PRs and say, oh, this is a bracket is on the wrong line, and so on and so on. I would say it's better to have a tool which does it for you, and you spend actually your time when you review on the logic, on what the actual PR does, rather than styling. So yeah, I know the Clang format is not the best tool. It has its own issues. Not all the styling options are available. Sometimes there is problems, but yeah, I still prefer to have this tool. The second one is a CMake format, basically the same as Clang format for C++, but only for CMake. Like C++ is so complex language that we even have a formatter for the build system. So it's kind of, funny in a way. I also would recommend you to run few linters like Clang-Tidy, which has so many different checks. It supports the CPP core guidelines. It supports some company specific like Google style and so on, LLVM. So very, very cool tool. I really recommend you to run. Sometimes it saved me several times. Yeah, quite nice, nothing to say. Yes, there is a Calazy, which is, if I remember correctly, kind of based on Clang-Tidy, but this is for the Qt projects. It's know about Qt specifics. There is Cppcheck, which is pretty simple static analyzer, but sometimes it's fine some places where to improve. So I also would recommend you to include what you use, because when you're in when you have a big project, and at some point you will have like included 5, 6, 10, 15 files, and actually only one of them is using, but the compilation and parsing is like increasing and slowly to build. So sometimes it's nice to clean up, and this tool kind of help you with that. I would also recommend to use commercial linters like PVS-Studio, Sonar, or find something else. They usually have a specific checks and specific heuristics to verify that your code works. I really recommend you to look at the PVS-Studio and their blog post, because they time to time take some open source projects like Qt, for example. And after that, you see that they find so many funny errors, which, yeah, it's just, yeah, C++. And after that, usually you see 20, 30 PRs to Qt, which says like fix wherever PVS-Studio found. So it's quite nice, quite interesting. I would also recommend to use pre-commit tool. I didn't know where to put it, but it's basically, as I said, Git doesn't have a very nice integration with what to do when you do commit or like some other operations. But the pre-commit is basically a framework around it, which allows you to add like Clang format, CMake format. It can be then on the Clang-Tidy as part of your commit step, for example. You want to commit, it will make sure that everything is great. It's very fast feedback for the developers, instead of like waiting when you push it on CI and so on. But also what it's allow you to do is actually set up a specific version of the tool, because Clang format, for example, breaks the configuration files between the major versions. Sometimes like you need to actually go and update it, and it's kind of hard. You can update it, but then like somebody's sitting on the old Ubuntu as a developer and he doesn't have that version. So it's pre-commit basically solve it for you. So I kind of like it. And also, as I said, fast feedback is quite good. So, okay. I think after you listened to me for almost an hour, you was thinking, okay, there's so many things. What if I just wanted to write the code? I don't really want to focus on all of this. Somebody set it up everything for me. I just want to write the code. So what to do in that case? And my answer is to select a good IDE. And I personally use Vim, and I spent many years to configure it, but I understand that that's probably not an option for everybody. That's why I kind of cross them out, Emacs as well. And I partially cross VS Code is because VS Code is not an IDE, but it has a lot of nice plugins, and the way how VS Code promote these plugins for you to install, it kind of helps. I found many times when I was sitting with the developers and they open VS Code and they don't know what the file says. Oh, this is a CMake file. You need to install CMake plugins, and now suddenly everything much better. So I kind of half crossed it. I also would recommend CLion. That's a commercial actually IDE, but it's in my opinion one of the up-to-date IDEs. Yeah, they have. Yeah, we will talk about CLion later. But I also need to highlight the Visual Studio. Visual Studio is quite nice, quite powerful. The only one issue is the Visual Studio is only on Windows. And that's kind of limited the scope because, yeah, not all development could have been done on Windows. You actually need to go on Mac, you actually need to go on Linux. So that's why kind of, yeah. If you're fully on Windows, this is probably the option. But if not, I would recommend to actually look at CLion. And quickly about CLion. In my opinion, this is the most complete code model. So it knows so much about your source code, and it can tell you so much about your source code. So I kind of, yeah, I have not seen, yeah, it's one of the best in my opinion. I would also say it's bundled and there's also integration with C++ tooling, so which is quite nice. Then you don't really need to think about it. It will pick up the configuration files from your project and automatically configures it. So it's kind of good. It's actively developed and maintained, which is quite nice. And I also would say for those who like Emacs, it's very similar user experience. You can just stay in that IDE and yeah, everything is there. So which is quite cool. And just for simple, small live demo, I think I have a couple of minutes left. I want to show them CLion. So let's open the project in CLion. I hope you can see that. So yeah, very simple. And as I said, it knows a lot about your code base. So this is our executable. And you can just press the run and it will run, which is nice. You can go to the tests and you can run the test as well. So it knows that it's a catch2 test. It knows how to run it, how to report. So it's cool. And recently they even added CMake debugger support. So it's kind of, yeah, it's mind blowing in a way. Like we in C++ even have a debugger for the build system. I just want to show you how it looks like. I think it's like truly amazing. I just put the breakpoint here. I will just run it. And now we're here. For example, we can look what this variable is and like a print, this is the result. So, I mean, yeah. And very interesting and very nice, in my opinion. So I also believe that such tools like debug of CMake can actually help you out to understand what the CMake does, because as I said, it's not easy at some point. So such things quite help. And yeah, for you, it's like a regular flow when you debug your C++ in a way. Yes. So yeah, as I said, it knows about your project. You can see on the right on the right bottom is that it knows about Clang format. It knows about my Clang-Tidy settings, everything out of the project, and kind of nice. And there is also one cool thing is that you can even enter the presentation mode, so it will scale down. Very small thing, but still nice when you do presentations. So kind of cool. Yeah, it also has a support of, as I said, the CMake. It knows about your. It even has support of package manager. It knows about VC package. The Conan has a plugin provided for the IDE, so yeah, you basically can focus on your work if somebody set up everything around. So that's nice. Yeah, as I said, it's very, very quick CLion view. Yes. So how to start a modern C++ project? I think we cover a lot. During the presentation, to preparing to the presentation, I actually created a small template, which you can just clone or use as a template. There is a small CMake script where you can set what's the project name, module name, and header name, and it will kind of configure it for you. If somebody thinking I'm in love with CMake, that I'm running the scripts in CMake, no, it's not true. The only reason is I did it because apparently there is no a cross-platform tool which is in a supplied by every OS. I tried originally using Seed, but then Mac Seed is Linux Seed is not the same. On Windows there is nothing. So yeah, and up to if you want to build a CMake project, C++ project with CMake, then yeah, script and CMake. But there is many other templates out in the internet. Just find the best. So yeah, it's just what I did during the preparation to the presentation, and kind of use it by myself. Yes. Thank you so much. And this is the links. There is a lot of there's a lot of good talks which I encouraged, which I read. Some articles which I read and some talks which I listened. So yeah, feel free to take any of that. And it's online, so I'm not sure if I will get any questions. So anyway, I will have this slide with questions here. I see that there was some things in the chat, but yeah.
Thank you for this great talk. If there are any questions, Mikhail will be on the table for the previous talk, which was this one. And so if Mikhail couldn't answer your questions during the conference in the chat, then he'll be there and you'll still be able to discuss this topic, which I think has a lot of topics and a lot of angles to discuss. So thank you very much for the great talk.
Yeah, and thank you for my pleasure. Yep. Good.
If you have any questions, see him in the lounge.
Mm-hmm.